We'll continue with the parameterization in calculus. So, whatever we have covered of vector representation and algebraic representation. So, we would kind of proceed from the vector representation and algebraic representation to parametric representation. So, that is the idea. Whatever we have been discussing that. So we have vector now. If there is a point called if there is a point called 2 comma 3 and I have a line from origin to 2 comma 3, then there is algebraic equation and there is a vector equation. So vector equation is nothing but if I have 2i plus 3j as vector equation, then it is kind of a summation. It is kind of a summation of two vector combination addition of two vector. One is 2i and one is 3j. So vector is nothing but energy source that has a direction and that has a magnitude. So if I have a vector 2i, then it has a direction along x-axis I and it has magnitude of 2. If I have a vector 3j, then it has a direction along y-axis and it has magnitude of 3. If these two vectors meet at the origin, then they go in a if they meet and then the net vector, it moves in a kind of direction where equation is 2y plus 3j. This is what we see. Now, if I see the slope of this vector dy by dx, then every 2 in x, there is 3 in y. So, 3 by 2 dy by dx. So, equation of the line would be y equal to mx. So, y equal to 3 by 2x. So, 2y equal to 3x. This is what we saw. So, if I say addition is the root of any mathematics, then integration is the root of calculus. If addition is root of mathematics, from addition everything has come out or derived, then integration is the base of calculus. From there, everything is derived. If that is true, then rate of change, that is also called slope, rate of change is the base of algebraic equation. So every kind of a singular equation or monomial equation in the terms of single variable or multivariate case, all their base is rate of change. So if I say y equal to mx, y equal to x, that is kind of a simplest equation of a line y equal to x, then a hidden rate of change is 1, y equal to 1 into x. 1 is the rate of change. So the way x is changing, same way y would change. If rate of change is 1, means y is changing in same way, same proportion as x is changing. Y equal to mx, y is changing m times to the change in x we see. So rate of change or differential derivative slope. So these are the factors are the base of the any algebraic equation. Now we can move with the polynomial or multivariable like z equal to m1x plus m2y. So along the x-axis, the rate of change is m1, whereas along the y-axis, rate of change is m2. So this is kind of equation, line equation, of monomial I can say because power is 1, multivariable. Polynomial equation sits on the monomial one. So the base of any algebraic equation is rate of change. So let's move kind of to parametric equation. So I have a vector called 2i plus 3j. Then what would be the parametric equation? Parametric equation we talk where the independent component is only when, whereas dependent component can be so many. If I say z equal to m1x plus m2y, then independent components are x and y. It is fxy, function over x comma y. Whereas the dependent component is z. So there is one independent component and two dependent component. There are two independent component and one independent, two independent component and one dependent component. Z is dependent upon x and y, z equal to fxy when z equal to m1x plus m2y or mx plus ny. So This is dependency and on independent component. What about considering only one independent component and rest others are dependent on them? Like if I say I have equation z equal to m1x plus m2y, then mx and y are independent component and z is dependent component. What about that x, y, z, all three are in terms of t1? Okay, so that is the scenario. So let's consider that I have a vector called 2i plus 3j. Now x component of this vector is 2 and y component of this vector is 3. 2 and 3. Now let's consider that I want everything in a variation of t. T is one independent component and x should be in variation of t and y should be in variation of t. So independent component is only t, whereas x and y both are dependent upon t. This gives a new arena of complex equations. Okay, so if we go in multivariable case in machine learning in those areas where the number of variables or number of features cross 4, 5, 6, in that way so many independent components are coming, whereas dependent is only one, and that is the class. Okay, so class is dependent. If this is the set of independent variable, then dependent variable is the name of the class, what it will where it belongs to. Now, when we come in the kind of in the parameterization, the independent component is only one, that is t. If t is the independent component, then x and y both are dependent upon the t. So if I have a vector 2y plus 3j, then vector has x component as 2, whereas the y component x component is 2, whereas the y component is 3. Okay. Now, what about the same vector? I can say 2ti plus 3tj. 2i plus 3j. This is the vector. So if this is origin, if this is origin, then 2 and 3 somewhere here. So there is a line. There is a line. If this is origin and this is 2 and 3, then there is a line. Along this line, vector has a direction and vector has a strength. So strength of this line is the length of this line. That is 2 square plus 3 square square root. So 9 plus 4, 13. Okay, square root of 30 is the strength of the vector where direction is 0, 0, 0, 0, 0, 2, 3. Whatever is the direction you can imagine, that is the direction. Now I can increase the magnitude. If I increase the magnitude, the length of this line is increasing, but direction won't change. Direction is fixed. So along this line, any xy, any x I can take, accordingly we will get the y, or any xy we can take. That is the concept. Now, if the equation is 2i plus 3j, then what is, suppose that this line I want it to grow. This line, suppose this line, it is at 0, 0 and 2, 3. Between this the line is, so strength of the line is a square root of 13. Where is this? This is the direction. Now line is moving. Okay, line is moving in this direction and it has it has a strength as 30 or multiply of 30. 13 into 1, 13 into 1.1, 13 into, I mean square root of 13. A square root of 13, 1.4234. So strength of the vector, we can keep changing, and its position also we can keep changing. So if vector is like this, then it can go like this, it can go like this. But the direction of the vector, still it will remain the same. It can move in a, so I can place offsets. So if this is y-axis, this is x-axis, this is x-axis, and this is y-axis, and this is origin. If this is the vector, then I can place offset like this along the y-axis. Now vector is this, where this is 0, 2. This is 0, 2, this is origin, this is y-axis. if I have a vector that is passing from origin, then if I give offset along y-axis, then it shifts 2 along the y-axis. Now it makes interception on the y-axis at 0. If I shift along x-axis, then it makes interception at the x-axis any point, 0, 1, 0. Okay, so if I have a vector, vector magnitude I can change, vector position I can change. I can put some offset in x and y direction, but direction of the vector will remain always constant. That is the idea. But anyway, now I have a vector 2i plus 3j. I can mention it as 2ti plus 3tj. Now t is independent component that is coming into the picture. And now we have x and y. So x is 2t, x factor is 2t, whereas y factor is 3t. Now, if t is 0, then this vector is at origin. If t is 1, then it is at 2, 3. If t is 2, then it is at 4, 6. If t is 3, then it is at 6, 9. So, this vector now I make it dependent upon a factor called t. So, x component and y component, they are dependent on the t. Now, if this is the vector that is 2ti plus 3tj, if this vector is going and it is hitting any sphere, x square plus y square plus z square equal to radius square with some offset. If I have somewhere in the universe, in the space, there is a sphere, and this vector is hitting the sphere, then at that point where it is touching the sphere, then x component I can replace with the 2t, and y component I can replace with the 3t, and z component will see. Then we can actually equal to radius square. Then actually we can calculate what is the value of t where it is touching the sphere. Everything in only one independent component, that is t. Anyway, we will proceed. This is parameterization. Parameterization in a sense that x factor, y factor in a vector, x factor, y. So vector generally we think as a static where it has a direction in I and j and k, where its values of for the I, the magnitude of the I, j and k are static. Now it is coming as variable. There is a independent component. Independent component means variable. So the vector, the vectorization. So when we imagine about the vector, immediately we imagine about the direction. So now vector has a direction, but the component of the vector x, y, z, now it is through a variable now. So as variable is changing, the kind of the vector direction will be same since it is dependent upon only one independent variable, but vector can move now. Vector can move now because it is dependent, it is not dependent upon a static variable, it is dependent upon a variable, okay, dynamic variable, that is t. T can also be considered as time. So when time is 0, it is at origin. When time is 1, it is at 2, 3. When time is 2, 3, 4, 5, 6, or minus 1, minus 2, minus 3. When the time was. At that time, where the vector was. Amazing, right? So we will see more on it. Now let's go with the 3D. Now I have a vector that is 2i plus 3j plus 4k. Means there are three vectors. One, if this is origin, 2i came to the origin, and 3j came to the origin, and 4k came to the origin. They combine each other and they move together in one direction. The direction is now, since all three are orthogonal to each other, now direction is 2i plus 3j plus 4k. Okay, so that is the direction, 2i plus 3j plus 4k. This is a new 3D vector. We can also imagine this like a position vector. If there is a point that is origin 0, 0, 0, then there is a point called 2, 3, 4. If I make a line from 0, 0, 0 to 2, 3, 4, whatever the line is, that is the vector direction, and the strength of the vector is 2 minus 0 square, 3 minus 0 square, 4 minus 0 square, square root. So that would come as 4 plus 3, 4 plus 9, that is 13, plus 16, that is 29 square root. That is the strength of the vector, whereas direction is 2i plus 3j plus 4k. But these three component of the vector x, y, and z, 2, 3, and 4. Actually, there are three vectors, unidirection vector along x-axis, along y-axis, and along z-axis, and they meet at origin, and that is the new vector. So, if I consider the vector notation of, then it is 2i plus 3j plus 4k. Okay, now let's consider the algebraic equation. So, algebraic equation is nothing but dependent based upon independent. That is the base of algebraic equation. As I say, the base of algebraic equation is rate of change. So, z equal to m1 x plus m2 y, where m1 is the rate of change per unit x along x direction. M2 is rate of change per unit along the y direction. So dz by dx is m1 and dz by d2 is m2. Z equal to dz by dx x plus dz by dy y. Okay, so this is the algebraic equation. Now let's see the vector 2i plus 3j plus 4k. If there is a change of 2 in x, there is a 4 change in z. So dz by dx is 2. Dz by dy is 4 by 3. Dz by dx is 4 by 2. Dz by dy is 4 by 3. So in algebraic equation, z equal to m1, that is 4 by 2x, plus m2, that is 4 by 3y. So z equal to 2x plus 4 by 3y. That will come as 3z equal to 6x plus 4. So this is equation of algebra, but this is the equation of a line or surface. Means the life, if you read any mathematics book, okay, you will start getting headache. Any mathematics book, they directly talk about the line equation, they directly talk about the surface equation, they directly talk about the volume equation, they directly talk about the 4D equation, 5. Or what is these equations are? They never discuss about it. Amazing. It's a painful to the head, right? Means it's a headache. You read any mathematics. That's why I say that all video we are making, all new things we are placing. So one disclosure per video is kind of expected and it is deserved also. So we will do that. We are committed to place 600, 1000 disclosures. That we'll do. Anyway, now if I say that z equal to 3z equal to 2x plus 4 by 3y, then it is equation of a line, or it is equation of a surface, or it is equation of a volume. Now there are two independent components. If this is a xy surface, then there is x and there is y. Okay, there is x-axis and there is y-axis, and this is vertical is z. Against each x comma y, each x comma y, there is a vertical. So suppose I have 4x comma y, 1x comma y here, 1x comma y here, one any haphazard way, random way, x comma y here, x comma y here, x comma y here, x comma y here. Guaranteed that they will be in a surface. For that, we have four vertical. One vertical is here, one vertical is here, one vertical is here, one vertical is here. It is something like this. Now tell me what it is. Down the line, this is xy plane. And at 4 point, this is 1 point, 1 point, 1.1. These are the z value against 4 point on the xy plane. If that is true, then if I connect all those 4 points and draw what it is a surface. So if I have two independent component and one dependent component, then this is nothing but equation of a surface. But you have to now put a binocular. You have to put a binocular or telescope or microscope to understand it is a line, it is surface, or it is a volume. If there are two independent, if I say my equation of anything, equation of a graph is 6x plus 4 by 3y minus 3z equal to 0, and it is equation of surface, people start there scratching their head, their hair everywhere. There are three things x, y, z, and how it can become an equation of surface, and then what is surface? Boss, algebra is nothing but it's a association of independent and dependent component. There is nothing more in algebra. It's a combination of or association of relationship between independent component and dependent component. There are two independent component x and y. If there are two independent component x and y, then x and y they makes a surface, that is xy plane. And with two independent component, we have n number of xy combination values. Okay, each value has a pair of x and y, and they all live in one surface against which there is a dependent component as z. If that is true, then for each x and y we have z value. If I connect all z value, it gives me a surface. Okay, so if this is the equation of a surface. If I have y equal to mx, then this is equation of a line. Okay, line lies in a surface, that is true. The net, it is lying in a surface. Y and x duo lying in a surface. If I say x, y, z trio, then they lie in a volume. Okay, but z value, what we are seeing, that is the equation of a surface. Anyway, now we have found it. Z, if there is a vector 2i plus 3j plus 4k, then equivalent algebraic equation is 3z equal to 6x plus 4 by, okay, so I'm sorry, I think we did kind of, okay, so actual is z equal to 4 by 2x plus 4 by 3y. So it will come as 3z equal to 6x plus 4y. That is true, not 4 by 3y. So 3z equal to 6x plus 4y. So 6x plus 4y minus 3z equal to 0 is the equation of the surface, whereas the vector equation is 2i plus 3j plus 4k. 2i plus 3j plus 4k is same as 6x plus 4y minus 3z equal to 0. So this is in form of vector. This is form of a algebraic equation. What is greatness about vector? Vector has a direction immediate. The power of vector is constant direction. Direction is constant in the vector. Whereas power of algebraic equation is rate of change. Immediately we can see that if I say that for 3z equal to 6, 3z equal to 6x plus 4y, then I can say z equal to 2x plus 4 by 3y. Immediately I can say that dz by dx is 2 and dz by dy is 4y. So slope is immediately I can get in the algebraic equation, that I can get in vector also. So if 2i plus 3j plus 4k means dz by dx is 4 by 2, dz by dy is 4 by 2. Vector is very powerful. It gives you direction immediately. It gives you slope or differentiation immediately. Vector is very powerful. Where the vector is limited is the x component, y component. It's very clear cut off. 2 is x component, 3 is y component, and 4 is z component. Whereas in equation like z equal to 3x plus 4, z equal to 3 z 4 3z equal to 6x plus 4y. What is x component and what is y component, what is z component, that we don't know. What we know is the slope, differentiation, derivative, that we know. Partial derivatives, those things we know. But here we know everything. What is lacking here is that variation. Multivariable we cannot put. In the multivariate case, polynomial case, everything is possible in algebraic equation. We can differentiate it, we can integrate it, we can calculate, we can have differential equation, everything. Okay, but here in vector we know x, y and z components, so we know the direction, but it is static. X, y, z are components are more or less static. That's why we imagine the vector anyway. So we now let's calculate the parametric equation. So if I have 2i plus 3j plus 4k, then parametric equation is 2ti plus 3tj plus 4tk. Now at t, if I consider t that is independent component, where dependent component earlier x, y was independent component and z was dependent. Now x, y, z all are dependent, whereas t is the only independent. So when t equal to 0, it is at origin. When t equal to 1, it is at 2, 3, 4. Now we keep changing the t and we keep getting the point in the direction of the vector. That is the gradient. So now the parametric equation is nothing but we have x value of the vector in the function of f, where y value in the vector in the function of g, and the z value in the vector is in function of h. So I can say f, g and h. So these are the functions in term of function where the parameter is t, function over t. So function over t for the x dependent component now. Function over t y dependent component now. Function over t z, that is dependent now. Independent is only t. With the variation of t, I can consider anything, time also. So with the variation of time, now we see the variation in the vector that we see. What about if I say that x is sine t, x is cos t, and y is sine t, and z is t. So if I keep varying the t, then cos t and sine t, that is xy plane, if I say, then cos and sine t, they vary in a fashion that they will create a circle. If t equal to 0, then it is only along x-axis we can see the value, because sine t 0 is 0. But if I grow that in time, then it will start making the point and it will come to a circle. I mean, this is the nature of the cos t and sin t combination. So cos t I vector plus sin t j vector plus t k vector. Now if I grow in time, then it start rotating in xy plane, but the z plane, okay, z is t. So z plane is growing like this. It is making a helix. What we see now? That we'll see now. Now, suppose that I have cos t, I have a line. I think better that we can say I have a line that is 2ti plus 3tj and 4tk. So this is a line 2ti, this is the origin. 2ti, 3tj and 4tk. Now this line has base as origin. Can I make an offset of 0 to 0 along, oh sorry, 0, 0, 2? So this is z axis. So along z axis, this vector I shifted 2. Now this vector has same direction, but it shifted 2. It is not touching origin now. Earlier, it started from origin and went in direction of a point 2, 3, 4. Now I made an offset 0, 0, 2. Now it is going in same direction, but certainly it may not pass through 2, 3, 4 or not pass through the origin. It has different set of points. So I can say this vector is shifted little bit up with an offset. 0, 0, 2. What is the equation of new vector now? So if I say 2i plus 3j plus 4k, then 2 shift 2, the x factor shifted